All right, let's take a look at number one. So here we're going to solve this physics problem that involves a spring and the spring's elastic potential energy. So a spring with a force constant of 5.2 newtons per meter has a relaxed length of 2.45 meters. When a mass is attached to the end of the spring and allowed to come to rest, the vertical length of the spring is 3.57 meters. Calculate the elastic potential energy stored in the spring. So, the problem states that we have a spring with a force constant, right? So we have that value. And please notice that the units are newtons per meter. We have a relaxed length in meters, so that's good. And then we have a new length once the spring has come to rest. And we want to find the overall potential energy that's stored in that spring. So remember, potential energy is simply energy that is stored in one form or another. So, some things that we know. We know the spring constant. (5.2 newtons per meter). Right? So then we know that the relaxed length versus the length at rest, the difference between those two things is going to be our x value. And so we're going to find the difference between those two things really quickly. And so that's going to end up being 1.12 meters. Remember, the equation that we're working with here says that elastic potential energy is equal to 1/2 kx squared, which I'm ready to plug and chug because the question is asking me to solve for elastic potential energy. So simply plug in my value of 5.2 newtons per meter multiplied by x. Don't forget to square it because that'll really throw you off. And my calculator, once I move this through, and again, this square right here, make sure you do not forget to square this before you do the rest of your calculation, because this exponent needs to happen first before the rest of the multiplication. So my calculator goes on to tell me, with two significant figures, right, because of this value right here limiting me, 3.3 joules of potential energy stored in this spring.